Right, we're going to multiply multiple digit numbers, continuing with this study of multiplication. In the last few videos, we multiplied single digits on the bottom, multiple digits on the top. Now we're introducing multiple digits on the bottom, so it just makes the algorithm a little more complex. Processes are still largely the same. Notice I don't have the grid system in this one anymore with the place value columns. I still recommend, if you have trouble organizing your work, using a piece of grid paper or graph paper to help you, because it becomes really important that everything lines up perfectly, as you'll see as we work through this algorithm. But for the most part, we start out the same. Just like we're multiplying 32 times 3, and that part is not there. 3 times 2 is 6. 3 times 3 is 9. So we've taken care of 32 times 3. Remember that in 32 times 33, it's really 33 groups of 32. Now we've taken care of 3 of those groups of 32. We have 30 now remaining. So in the next line, we're going to take care of the 32 times 30 now. It's the bottom number. Because this 3, remember, is in the tens place, so it's actually worth 3 times 10, which is worth 30. So this is going to be 32 times 30. So 30 times 2 is 60. We can remember to drop a 0 in there. We always have to drop a 0 in there, but that's why. A lot of times you're taught just to memorize that. But really, this is 30 times 2. So 30 times 2 is 60. That's where the 0 comes from. And then 30 times 30 is 900. So 960. Now, as you're working through the algorithm, you really don't think about that because it's too much to think about. You're just literally thinking about drop a 0 in there. 3 times 2 is 6. 3 times 3 is 9. That's what needs to be going through your head. But in reality, this is 30 times 2, which is where the 60 comes from, which is why that 0 is there. And this is realistically 30 times 30, which is 900. And then we've taken care of that bottom row. So 32 times 30 gives us the 960. 32 times 3 gives us the 96. So we've taken care of all 33 groups now. And that's how the algorithm works. Now the final step, of course, is we just need to add these up. And the final answer is 1056. All right, let's do another example. And I want you to watch this example. I know you probably, if you have the process down, that's great, but I want you to see the reasoning because it helps with understanding. 42 times 21 this time. Again, by the algorithm, we just start by multiplying the 1 in the units place times 42, which we know is going to be 42, so we've taken care of 42 times 1. Again, we have 21 groups of 42. This is taking care of one of those groups. Obviously, there's 42. Now we need to take care of the other 20, so the next line's going to represent 42 times 20. So we actually have 20 times 2, which is 40, and 20 times 40, which is 800. So 42 times 20, and we can see pretty easily that's going to be 840. Again, eventually you want to be fluent enough with the system that all you're really thinking about is when I go to the second row, since I'm multiplying by 10, a 10 that's kind of covered up, I put the 0 there as a placeholder to take care of that 10. Then in my mind, I'm just saying 2 times 2 is 4, 2 times 4 is 8. If you think about all the stuff I'm talking about, every time it just becomes too cumbersome. So you need to become really efficient. Now, in the practice that you don't have to show this piece. I'm just showing you that for the sake of understanding. So you don't have to jot this down on the side. I'm just literally showing you how we take care of each of these numbers. 42 times 1 is taken care of in the first line. Then we move over to the digit in the tens column, and it's 20. So we got to take care of the other 20 groups on this second row. So 20 times 42 equals 840. Just so you see, it's not, a lot of people think the algorithm is something that you just memorize and it's just a process that's been developed randomly and you have to memorize it. You can see that's not true. Place value, the value of each of these numbers is built into that system. Yes, we have to come to the place where we're so efficient at it that we don't even think about this stuff, but I want you to see that it's still built in there. So go get some practice.